So hello everyone, and give me a thumbs up if you can hear me. We are here. Welcome to our first community conversation session for the year. This is for Technomatics, our virtual user group. I'm Taryn Blake, Community Engagement Program Manager for the Siemens Software Community, and I'll be your host for this enablement session. As you can see, our topic for today is job shop basics. So we're looking at push controls. Our speaker, you're probably familiar with Mr. Stefan Bongso. He is a freelance simulation expert and has been doing this for many years. He's completed hundreds of projects and training sessions. He has 5 published books on plant simulation. We were just talking about his 6th book, perhaps his last, but we appreciate everything that he's done for the Siemens PLM community and look forward to another session. So the big steps for today will be creating work plans and bills of processes, modeling your production program, and then implementing basic routing without connectors. So as I mentioned, we will have the live Q&A. Stefan is on live as well. You just raise your hand at the end. You can come off mute. We'll get your questions answered. So that is all for the introduction. And Stefan, you are welcome to take the screen.
Thank you. I take the screen. Hello again with this new year. We are starting the year 3 with our series, I guess, again, so around 20 webinars we will do. And today it's a quite basic topic. It's how to control a job shop model. There are several problems or objectives if you do some such models. Mostly the dimensioning of the job shops is enough capacity available for the work you have to do. If you need to extend your production, where it's where is a place you need to expand, in which job shop you need to do. And the basic thing with job shops is that the organization of the production is not in a straight line. The organization is done by technologies. You have special areas where you have special machines and do a special work. The most common job shop is the paint shop, where we have all the equipment located that you need to make a painting parts, and all the equipment is only there. You don't have a lot of different paint shops. Maybe you have only one. And if you have productions with very different production steps, and each part has a different technology, then maybe your production is organized in shops. Maybe you have a shop for drilling or milling or turning, and this is only the organization of the production. And the main problem is that each part may have a different process, bill of process, and needs to run through the production in a different way. And so you cannot work a lot with connectors. Basically, the push control is the main control in plant simulation. If you create a basic example with a source and station and train and connect this with connectors, then the type of organization or type of control is push control. In the earliest moment, the source will move the part to the next to its successor. It will push the parts to the successor, and the same from the station to the train. if the train is empty and can receive a part, then the finished part will be pushed to the train. So the push control, this is the main type of control in plant simulation. There are other control types like the pull control. We had already one webinar for this topic. It's running from the consuming point of the part, and then it pulls the part, next part from the predecessor. But this is not the default control in plant simulation. Okay, I start with a very simple example. I have two parts, part E, part B, from the user objects here in the class library. And I need to extend these two parts by a user-defined attribute. So I opened this part here in the class library and add a user-defined attribute with the name OP for operation. This should be a data type integer, and the start value here for a new part is 0. And the same for part B. Create a user-defined attribute anew with the name OP. Data type is integer, and the value should be 0 if you create a new part. The main instrument for control parts here in a job shop are the process steps or bill of process or process plans. And so I create a data table with the name process. And you will get the process steps maybe from your ERP system, maybe from SAP, mostly in Excel format, but we need a special format here in plant simulation to be able to process the data easily with SimTorque. And so I want to use one process table for all parts you have here in the production. And maybe you need to write a little program later to import data from Excel into this process table. I want to use the column index and row index, and the row index should contain the parts. So I can use the part name as a key to find easily the right plan for this part. And the names of the MUs is part E and part B. And in the second column, I want to have a table. So I format this as a table. And if you select table as data type, then you get a tab contents. And with this tab, you can format these subtables. And I want to have a column index. And I need at least 3 different columns. First should be a description of the step. Second is a shop where this step should be processed. And the third column is proc time. and we need to change the data types. The shop I want to have here as a string, and prop time needs to be time. So I format this column as time. You can place here more information about the process, but for our basic example, this is enough. So I click apply, and this column this should be the bill of process or process plan. And if you can type something into this cell and then press the key F2 or double click, and then you come into the subtable. I want to have 3 steps here. For the part E, it's milling, maybe drilling, and as a last step, washing. And the shops should be A, B, and C, and some prop times. 1 hour, 1 hour and 30 minutes. And washing is 20 minutes. So this is my production, my process plan for part E. And now I need also one for part B. So I type an X here and double click. And this could be milling, for instance, washing, painting. In reality, it's maybe tens of steps here. And it's really not rare that you come back into that you have washing several times. Maybe you have so maybe you come back to the same shop in a later step of production. Okay, then 2 hours, 20 minutes for washing, 2 hours for painting. And now we have a plan for part B. And we have organized all these plans in one table, data table. And you can add hundreds of parts here with the bill of process, and have only one place where you need to call in SimTalk, where you can access all the information you need in SimTalk. And so this type of organization is very, very good for programming. Okay, now I want to create the basic structure of the production. Please duplicate here or duplicate this station, because at this station I want to change later on, and I first change the 3D. Okay, oh no, I only want to change the 3D properties. I make it smaller, 0.5, and just scale the station. So I get it on one screen here, I hope so. Okay. It starts with a source, and the source should create part E and part B, and so I need a data table for the source. And I connect this data table with the source. Okay. It's now sequence cyclical. I want to have random. This will reformat the data table. And now I track these two parts into the data table, and it should be 70% part E and 30% part B, and each one this can represent, for instance, one lot of part E and one lot of part B. This may be a delivery table. If you have real data from your production system, then it could be the production order of parts from reality, from the future, or from the past. And then maybe you can change this here. Instead of time of creation interval adjustable, you can change this to a delivery table, and then you can define the time and the parts you want to create at a certain time. And there you can also create defined absolute times and can import this data from external system, for instance. Next, I need a buffer, entrance buffer, and at the end of this buffer, I want to change. I want to define the job I need to go, and now I need 4 buffers. I changed the buffer setting here in the class library, added 3D properties, and go to caption and activate the caption that you can see here, the names of the buffers. First should be buffer underline A. This is the buffer entrance buffer of this shop A. And then we need a buffer B, buffer C, and buffer D. And it's very important to follow some rules in naming the buffers because I want to address the buffers dynamically with buffer underline and then the name of the shop you need to go. So 3 buffers, and then we need several machines inside, several stations inside the this shop here, and this I create with the stations with the duplicate station here, because I want to extend this station, and so I take this station, and the first shop, the shop A, should have 3 stations. I just connect them with connectors. The shop B should have 2 of the stations. C only 1. And D has 2 stations. And we need, of course, a drain at the end. So for the each shop has its own queue here, and you can use the exit behavior of the buffer to decide which of these machines I want to occupy with the next part. And you have a lot of different, strategies here in Plant Simulation that you can use to distribute the parts to the stations. You can also write your own program for this. This would be just an exit control where you can make your own decision what machine you want to occupy. For the stations, we need two controls. We need entrance control to set the processing time, depend on the step and depend on the part that's coming. And we need the exit control to decide for make the decision what is the next shop we need to go with this part, or do we need to go to drain because the processing is finished. And so we need two controls here. We need station entrance and station exit control. I create this here in the frame. Station entrance. And the second one, station exit. And I assign these controls in the class library. Open the station, controls. The entrance control needs to be before actions. So the change in processing time influences the part that's coming here on the machine. And so we need to select before actions, and I just write here station entrance. It marks this red, but okay. And exit control should be station exit. It doesn't find station exit here in the class library and the user objects folder, and so it marks it red. But if you have a look into one of the stations here, then you see it isn't red. It's okay. Okay, two small SimTalk programs. It's not a lot of programming today. Station entrance. I want to set the proc time. I use the anonymous identifier question mark here to address the station with the control, and all my data are in process. The first column, and at point name, this is the row I want to address, and then inside the subtable, it's the third column and the operation number I get from OP. The attribute OP in my part. And so I can set the processing time dynamically. And this, in the same way, you can set as a formula in the processing time field. It has the same, it would have the same effect. Okay, this is the first method I need to set from my process. First column, the name of the part. This is a subtable. Proc time is in the third column, and this is the step 1, 2, 3, and here I find the processing time for each step, for each part. So station exit, here we need to increase the operation number, and then we need to read the shop also from the process table here from our column 2. There I have the shop, and from this shop name I can create a dynamical link to the right buffer, and then I move. If the buffer isn't full, I need to wait until the buffer isn't full, and then I can move the part to the right buffer for the right shop. And so we need some line of SimTalk. So first I increment the OP. And then I need to look for the next shop. I make 2 variables for this. One is shop str as string, and a second one is shop buffer. As object. And again, the source for all the information I need is the table process. And I get the next shop from process 1 at .name. And in the subtable, I need to address the second column, and at point OP is the next. It's the next step. I increased here OP, and so I find the next shop. And now I have 2 cases. The first case is there's some shop ABC, and the second case is there's no shop anymore on my table, and this means okay, the production is over. I need to move to the train, and if this is not empty, this field, then I can create a reference to the shop buffer. And I use here in this example the method extend pass. With extend pass. It come here. Is it? Extend. Okay, there's yeah. So extend path. I can hand over a string, and it creates with root. Root is here models, model. Then it creates from this one reference a path, and it returns an object. And so I need to create a string here, and the string is buffer underline plus my variable job str. And so I can create a buffer from buffer A, for instance, so I can create an object reference dynamically. You can also use str to object. So you can create a string here, buffer A, and with str to object, you can create an object reference from this. Else means job str is empty. It's empty. It's not string inside this cell, and then this means all done. And we go to train, and my variable job buffer in this case is just train. So it's quite easy. If you organize your information in the right way, then you have one big information source with all the process information you have. And you only need to set this information in the stations, and this you can also use to find the right place for the next step. And then we need to wait until job buffer is not full. And then you move the part to job buffer. Okay. You need to look for the end. Okay, this is not here. Is not if you have an exit control, maybe you have automatic created add move, and you need to look if you have a second add move here. This would cause chaos. Okay, let's have a look. So you see, okay, here in this buffer, there's a lot of parts, but it doesn't go further. The reason is this buffer also needs to have this exit control to find the first production step. And so I take just this station exit, move it on the buffer with drag and drop, and then it will be the exit control of the buffer. And now it should start. So you can now look for the right operation numbers here and the right parts and the right times. Here it's washing, it's only 20 minutes. And here it takes 2 hours, I guess, or 1 hour 30. You can check the operation number here. It's OP2, and then you can look in your process table if, moment, this is part E. In step 2 is drilling. This should be in the shop B. So this is okay. And now you can create a chart. I take this chart. Then I mark all the stations here. And track it on the chart. For the resource statistics, and let it run for a while. And this is one of the important insights you get from such a simulation. So now I have station 3 and station 4. Station 3 and station 4 are occupied 100%. It's working all the time, and this is our bottleneck. So the stations before, station 1, station 2 here, station 1, station 2, they are blocked here. Yellow is blocked, and this is also, it's before the bottleneck. And if you want to increase your throughput, you need to change the shop number B. This is if you need more capacity here. It will be more interesting if you include availabilities and all this stuff. And if you have a wider spread of parts, more parts, and then it's very, very difficult to calculate with Excel where you have a bottleneck in such a system. And you can create such simulations in it's take not a lot of time, and you can extend this simulation very fast. I made these simulations for more than 4,500 parts. The most time you need is to acquire all the process plans. But if you have included all the process plans in your simulation, then you can create a lot of experiments and can show, okay, with this production plan, you get problems in this shop, or you need to increase the capacity in this shop, or you need to create a complete different way of organizing your production. Okay. These are the basics for chop shop push controls. Yes, you can combine this with the webinar about the exit behavior. And the exit behavior webinar shows how to distribute parts to different successors. And this is strong connected with this chop shop controls. If you notice from your practice from companies, this is a big point of problems you have to solve. If you have a queue in front of a shop here, and how to organize this queue. Do you work with priorities, or with lead times, or there are so many different ways to organize these queues, and complete controls. Manufacturing execution systems mostly deal with this kind of problems. And in the discrete event simulation, we have a higher view, and we look, okay, if it's fitting here, do you need more capacity in some way, or how to organize this? And here we can really do a good job for companies. Okay, we share this model together with the video. I placed the model in the virtual user group.
You should see on your screen right now, it's an image of it's a screenshot of the forums, and it's also an animation showing that you should follow the topic of the plant simulation virtual user group. So the links you see, you can click on them right now. If you haven't been to that page, please click and go to the page. You can also, again, follow the topic, and you want to make sure that you go into the envelope icon and select every post. And that will make sure that you get emails from the system immediately. So system emails for new registration links, system emails for the recordings when it's posted on Friday. If you are following that topic and have every post selected, then you'll get an email right away. You could also ask questions. So if you watch the video or a colleague watches the video later after it's been posted there and you have a question, you can always mention Stefan there to get your questions answered. So I do want to call out Stefan's next sessions with us will be on January 28th, which is cross-sliding cars, CSCs. And then also on February 11th, we'll have a session on material flow analysis and statistics. So that's a bit about the forums, and that's also where the model will be posted underneath the recording. So on Friday, I'll post the recording, and Stefan shortly after that will post the model to answer that question. So yeah, it looks like we have a couple of questions about the presentation. So I don't know, Stefan, if you'll want to take the screen back to show them. Umang has a question.
Okay, can you share how to incorporate scrapped units in this model? Maybe send them to a separate train object? Yes. If you want to have one statistics about the parts, you can find this here in the train, and there's type statistics and detailed statistics table. And here you can find the portions of the part. Part E is 69%, part B 30%. If you want to have complete statistics, including your scrap part, then the easiest way would be to rename the part here when you mark them as scrap and send them directly to the train. So you have the part E scrap maybe here also with the percentages. This is the easiest way that you can create meaningful statistics. And so this is one really easy way to do this. If you have a separate train, then this separate train has its own statistics, and you don't have the relation to the complete number of parts. Okay, the buffer has the same exit control as station exit here, and so it's the second question: what control methods did you use for the main buffer? Yes. Side note: if using the entrance control to set the process time, you need to initialize the process time within the init method. Otherwise, the simulation run might not be reproducible. Okay, the entrance control before actions will be called before the part reached the station, and this will set the process time for the part that's coming, and so it's not necessary to set the process time to 0. You will get an error message if you don't set the controls before actions. And so there's no processing without part, and so it's doesn't have inference if you set the process time to 0 before. I was wondering how do you would suggest simulating a production schedule for job shop environment, such as a schedule generated by an APS system? Okay, I had this questions several times. It depends what you want to do. If you want to just monitor the plan, if you have a plan, okay, part E starts production 10 at 10 and 30 minutes and 50 seconds, and finished this at a certain time, and then it goes to next station and start production there at exactly 12 hour exactly at noon, and so on. If you have really times, then you cannot use the event controller. Otherwise, the event controller will start the time. This is not the simulation we do here in discrete event simulation. You need to send the part and then stop the machine and start the production at exactly the time you have scheduled. It's in the meantime, it's easier to do this in plant simulation. You can deactivate automatic processing, move the part to the machine, and then you wait in the machine until the time you have scheduled in your system. If you until the time is has reached, or until the simulation time has reached this time, and then you can start the processing with SimTorque. And so it's possible to create the production exactly like your plan is. But then you cannot have any stochastic influence here in the simulation, like failures or availability of resources. And then it's only playing the schedule. But it works. Now you can do this here with start processing. You have the SimTorque command for this, and you just need to wait until the time is. For me, it's not a simulation, it's just a visualization of your schedule. And so we need to be carefully not to fight against the event controller plan from plant simulation.
I always have more announcements. So again, if you didn't get a chance to click the link for the forums, definitely do that on the screen. But our team that does the Siemens Accelerator Academy, they do like us to let everybody know there is comprehensive education for some plant simulation topics that are listed on the screen there. You can also click on any of those links that you see to get to those areas on the web. There's also a plant simulation associate certificate. So if you're new to plant sim, that might be something that's useful to you and something to look into. Apart from that, Realize Live. This event happens in the Americas, Europe, and APAC. So we've been in India the past 2 years, in Detroit, and then in Amsterdam for the past year. So this is in person for customers, end users, and all the management and stuff too. They'll be presenting updates to all the software, and then just a lot of useful info on how to get the most out of the tools. So I know Stefan will be there, as will some of our other community catalysts, and we'd love to see all of you there at one of these locations in person. Stefan, I think America's in Europe, right? We'll be there. So also, if you're interested in presenting, that's what's on this screen. There's still the links until next week. You could submit a topic to be a presenter at Realize Live as well. So just wanted to make that known in case anyone was interested. That's literally all I have. Again, links to the forums, Stefan's profile here, a link to his community profile as well. And we've got a few more minutes. If you're holding a burning question, this is the time to ask.
Oh, thank you.
Yeah. Thanks, everyone. Yeah. We'll see you in the forums, I guess.
Yeah, see you on the forums.
All right. Bye-bye.
Okay, goodbye.